Good morning, afternoon, or evening. This video will cover numbers 1 through 14 of the Adding and Subtracting Linear Expressions guided notes. First, let's talk a little bit about what a linear expression is and is not. A linear expression is an algebraic expression in which each term is a constant or the product of a constant and the variable raised to the first power. So it's going to be really important is that your variable is in a separate term from your constants, separated by addition or subtraction, and that you have an exponent of 1 on that variable. So when we look at some examples, that includes 5x, 3x plus 2, 1/2 x minus 5, and negative 4x plus 3. Well, you don't have to use the variable x. What we do notice is that the exponent on the variable is always 1. So 5x to the first power. We don't typically write the exponent of 1. 3x plus 2. We see that the 2 and the 3x are in separate terms. 1/2 x minus 5. Again, we have that exponent of 1, and we have those terms being separated by addition and subtraction. Same thing with that negative 4x plus 3. Now, some non-examples include negative 5x squared, 6 over x, x cubed plus 2, and 5mn. Those are not linear expressions. What we notice in this first example is an exponent of 2. In the third example, we notice an exponent of 3. Now, this last example, the reason why it's not a linear expression is that your m and your n are being multiplied. Those variables are being multiplied rather than being in separate terms. So if we said 5m plus n, that would be fine, but not having 5mn all being multiplied. Now the 6 over x, that actually means that x has an exponent of negative 1. We'll talk about negative exponents later on this year, but you can't have a variable in the denominator of the fraction in order for it to be a linear expression. So in our examples we're about to see, I mixed together the adding and subtracting linear expressions problems. I think this is important so that you really pay attention to the details and see, is this an adding linear expressions problem or subtracting linear expressions? So when we're adding linear expressions, this is actually really quite easy because if we have, for example, 9x plus 7 being added to the linear expression negative 2x plus 6, really all we're doing is something we've done before. We're able to drop off the parentheses once everything is addition, and we'll see in example 2, we will rewrite subtraction as addition in the problem. But once everything is addition, we're allowed to just drop the parentheses and move the terms around however we want. So that involves us moving the like terms side by side. So you're going to notice that I put, and I want to highlight this here, so give me a chance to grab my highlighter. I want to put my 9x and my negative 2x together and my constant 7 and 6 together. And I'm allowed to add 9x plus negative 2x to get our 7x. And of course, 7 plus 6 is going to get us 13. So our final answer here is just 7x plus 13. So nothing fancy. Just rewrite subtraction as addition, drop the parentheses, put the like terms side by side. You're probably getting to the point where maybe you don't need to reorder the terms, but I think it is helpful to put the like terms side by side and then combine them together. And since we can use calculators in this unit, it should be pretty straightforward. Now, our second example is a little more complicated because we do have subtraction in 2 different spots. We'll go ahead and highlight it here in blue. I did start by rewriting negative 4x minus 2 as negative 4x plus negative 2, and negative x minus 5 as negative x plus negative 5. Now, it might not be a bad idea to write that as a negative 1x, add a coefficient in front of the x term. It's up to you. Now, once we reorder the terms, which again we can only do once it's all addition, we've got negative 4x plus negative x. Keep in mind that is negative 4x plus negative 1x, and that's going to total to give us negative 5x. And then our constants are negative 2 and negative 5. And negative 2 plus negative 5 is negative 7. Now, if you write your answer like this, negative 5x plus negative 7, that's fine. You do want to recognize, though, that that is equivalent or equal to negative 5x minus 7 if we undo adding the opposite, if we undo rewriting it as an addition problem. So just recognizing that these 2 expressions are equivalent is kind of important for us. Now, if the problem involves subtracting linear expressions, this is a little bit more challenging. So just like when we subtract integers, we will add the additive inverse or opposite. So we're going to start by practicing identifying the additive inverse of a linear expression. To do this, you're basically going to multiply the linear expression by -1, but make sure you rewrite it as addition first. I think that does help. So if we consider the expression 5x minus 7, I started by rewriting it as 5x plus -7. Now in order to write the additive inverse, I multiplied this by -1, and it's like using the distributive property. Now you're probably going to get to the point where you don't have to show all of this work for the additive inverse. In fact, we'll skip a lot of it as we get into our practice. But if I take -1 times 5x, that's going to get me -5x. If I take -1 times -7, that's going to get us +7. So the additive inverse of 5x plus -7 is -5x plus a +7. We're basically making each term its opposite. So think, what is the additive inverse then of -7x plus 3? If we make each of these terms their opposite, that's going to become +7x plus a -3. But you can also rewrite this as +7x minus 3. Both are equivalent, and I just want you to be in the habit of recognizing both of them as being equal to each other. You don't need the parentheses around the -3. Now, number 3, I did start by rewriting 3x minus 6 as 3x plus -6. And in order to write the additive inverse, I have to multiply each term by -1. And -1 times 3x is -3x. -1 times -6 is +6. So our additive inverse will be -3x plus 6. Again, it's the same as just making each of those terms their opposite. All right, our last two of these, -9x plus 3. We don't need to rewrite subtraction as addition. We just have to make each term its opposite or multiply each term by -1. -1 times -9x is +9x, and -1 times 3 is -3. So this is going to be, the additive inverse is going to be 9x plus -3, but we can also write it as 9x minus 3. Now for number 5, I do recommend rewriting this as -4x plus -8 first, and then multiply each term by -1. -1 times -4x is +4x, and -1 times -8 is going to get us +8. So the additive inverse will be 4x plus 8. All right, now there are some examples typed up for you. I want you to always keep in mind, like example 3 that's here, if you notice that you see subtraction in between those parentheses, one of the first things I'll always do is rewrite everything in the parentheses as its opposite. Or subtraction as addition. I guess I shouldn't say everything as its opposite. Let me restate that. I do want to rewrite subtraction as addition first. So when I found the additive inverse of 3x minus 2, since this was subtraction, I did rewrite it as 3x plus -2. So the additive inverse of that is -3x plus 2. So I'm going to add the additive inverse, which we identified as -3x plus 2. Once everything is addition, you're able to reorder it with like terms side by side. 6x plus -3x is 3x. +5 plus 2 is going to get us +7. Now I want to look at example 5 and then we'll bounce back to example 4. Example 5, we have a subtraction problem again. So we need the additive inverse of -5x plus 7. So the additive inverse of that is +5x plus -7. And I'm allowed to change subtraction to addition. It's like keep, change, opposite. Everything here becomes its opposite. So this becomes 5x plus -7. Once we do that, we can drop the parentheses off. -8x plus 5x gets us -3x. +2 plus -7 gets us -5. And then we can rewrite that as -3x minus 5. Looking at example 4, our last subtracting linear expressions problem, I did start by rewriting -3x minus 9 as -3x plus -9, and then down below I want to find the additive inverse of -8x minus 7. So I did rewrite it as -8x plus -7. The additive inverse of that is going to be +8x plus 7. You're going to make -8x its opposite, -7 its opposite. So we'll change that subtraction to addition here, and we'll make the thing that came after subtraction, its additive inverse. So we're going to replace negative 8x minus 7 with its additive inverse, which is positive 8x plus 7. We can then reorder this so our like terms are side by side. Negative 3x plus 8x is 5x. Negative 9 plus 7 is going to get us negative 2. Now, either of these examples or answers are acceptable, so you could write 5x plus negative 2 or 5x minus 2 as your solution. All right, let's try some. Feel free to kind of try some of these things on your own, but definitely double check and make sure they're correct. Pause the video as needed as you're copying some of these things down as well. So number 6, I noticed right away that this is an adding problem. So I don't need to change anything, and in fact, everything's already addition. So I'm allowed to just drop the parentheses, reorder it so the like terms are side by side. So I dropped off my parentheses in my first step. You might be able to skip that. And then I reordered it. So my 6x plus 5x, my like terms, are side by side. And my constants, 8 and 12, which are also like terms, are side by side. When I add 6x plus 5x together, I'm going to get 11x. When I add 8 and 12 together, I get 20. So my final solution here is going to be 11x from adding my two constants, my like terms together. And then 8 plus 12 gets me 20, and I get that from adding my two constants together. So final solution, 11x plus 20. I do want to stress that at some point you probably aren't going to need to show too much work for a pretty simple and straightforward problem like this. But if we follow those steps consistently, we'll make sure to get it correct every time. All right, taking a look at number 7. So this one is a subtraction problem, noticing that right away. So the first thing I actually did was I rewrote everything in the parentheses as addition. I think that's a good idea before we identify additive inverses. We need to do that anyway before we reorder the terms. So again, I'm going to highlight that subtraction again because we're going to keep that in mind. So 3x minus 4 I rewrote as 3x plus negative 4. I kept my subtraction for now, and x minus 5 I rewrote as 1x plus negative 5. Now, all I did was rewrite the problem. I didn't add the additive inverse yet. So my next step is going to change that subtraction to addition and use the additive inverse of 1x plus negative 5. That's going to be negative 1x plus a positive 5. So when we rewrite that, it's going to look like this. Again, we're going to add the additive inverse. So the additive inverse of 1x plus negative 5 is negative 1x plus a positive 5. Once everything is addition, which it is here, we can drop off those parentheses. We can reorder it so our like terms are side by side. So I've got 3x plus negative 1x and negative 4 plus 5. 3 plus negative 1 is going to get us 2x. Negative 4 plus 5 is going to get us positive 1. So our final solution here will be 2x plus 1. For the next problem, I noticed that it is an addition problem, but I did start by rewriting subtraction as addition inside the parentheses. It's kind of important for us to do, so negative 8a minus 4 became negative 8a plus negative 4. Negative 5a minus 13 became negative 5a plus negative 13. Again, once everything is addition, I'm allowed to move the like terms side by side. So that's going to become negative 8a plus negative 5a. And then my constants are negative 4 and negative 13. Negative 8 plus negative 5 is going to get us negative 13a. Negative 4 plus negative 13 is going to get us negative 17. Now we can keep our answer as negative 13a plus negative 17, or we can rewrite it as negative 13a minus 17. Number 9, I'm going to notice right away that this is already an addition problem. So it's already written as addition, but I am going to rewrite things inside the parentheses as addition. So negative 6x plus 11 plus the negative x minus 9 I rewrote as negative 1x plus negative 9. Once everything is addition, I can drop those parentheses, move my like terms side by side. So negative 6x plus negative 1x. And then, of course, our constants are 11 and negative 9. So negative 6x plus negative 1x will get us negative 7x. And then 11 plus negative 9 is going to get us 2. So again, the negative 6 plus negative 1 gives us negative 7. 11 plus negative 9 is 2. Next question, I noticed right away it's subtraction. So the first thing I did was rewrote subtraction as addition inside the parentheses just to make that step a little bit easier. Since I do have subtraction here, I need to add the additive inverse. And the additive inverse of negative 6x plus negative 1 is positive 6x plus a positive 1. So the first thing stays the same. I'm going to keep that, negative 5x plus negative 9. I change subtraction to addition, and then the additive inverse of negative 6x plus negative 1 is positive 6x plus 1. All right, let's put our like terms side by side. So we have a negative 5x plus 6x. Those are like terms. We have a negative 9 plus 1. Negative 5x plus 6x is going to get us 1x. Negative 9 plus 1 is negative 8. So we can write this as negative 1x plus negative 8. You can also drop off the 1 in front of the x and rewrite this as either x plus negative 8 or x minus 8. That will also work for us. All right, next one, number 11. I see again this is subtraction. We don't love those. We did switch up the variable to b here, but that's okay. First thing I want to do is rewrite negative 7b minus 14 as negative 7b plus negative 14. For right now, since I didn't do the additive inverse, I kept my subtraction. b minus 5 is the same as 1b plus negative 5. Now the additive inverse, I do want to add that additive inverse. The additive inverse of 1b plus negative 5 should be negative 1b plus a positive 5. So we can see that we have that there. We added the additive inverse. Now drop off those parentheses, put your like terms side by side. So we've got a negative 7b plus a negative 1b, and we have negative 14 plus 5. Negative 7 plus negative 1 for the b's is negative 8b. Negative 14 plus 5 is negative 9. Now you can write it as negative 8b plus negative 9. You can also rewrite it as negative 8b minus 9. Both are correct. All right, our next problem throws in some fractions, but what we notice right away is that this is already an addition problem. So I am going to start by rewriting the 1/2 x minus 3 as 1/2 x plus negative 3. Remember, I don't need to make 1/6 x plus 1 its additive inverse since it's already addition here. We'll highlight that again just to make sure we keep in mind this is already addition. Once the entire thing is addition, we can drop those parentheses. We can put our 1/2 x plus 1/6 x side by side. Negative 3 plus 1 are constant side by side. So we'll want to add our fractions together, so these guys right here, and our constants of negative 3 plus 1. And we can use calculators for this. 1/2 x plus 1/6 x is going to get us 2/3 x. Negative 3 plus 1 is going to get us negative 2. So you can write this answer as 2/3 x plus negative 2, or equivalent to that is 2/3 x minus 2. That will also work. Next one, unfortunately, is a subtraction problem, but I am going to start by rewriting everything inside the parentheses as addition. So the 3/5 x plus 3/4, so let's get back up there. 3/5 x plus 3/4 is going to stay the same. I kept subtraction for now because I did not use the additive inverse yet, but I did rewrite 1/3 x minus 1/8 as 1/3 x plus negative 1/8. Now we've got to do that additive inverse. The additive inverse of 1/3 x plus negative 1/8 is negative 1/3 x plus a positive 1/8. So I change subtraction to addition, and then I add that additive inverse, which, as we already said, is negative 1/3 x plus 1/8. We can drop off those parentheses and put our like terms side by side. So that's going to be 3/5 x plus negative 1/3 x, which we can use our calculators to combine, plus 3/4 plus 1/8. So when we go to work through this, we've got 3/5 x plus negative 1/3 x. When we combine those, that is going to get us 4/15 x plus 7/8. That's 7/8 we get by doing 3/4 plus 1/8. That one's a little trickier and definitely helpful to have our calculators handy so it gets those common denominators and everything like that for us. All right, our last question here is number 14, and we notice this is another subtraction problem. I probably put more subtraction problems in here just so you get practice with subtracting linear expressions. The First thing I did was rewrote everything inside the parentheses, kept that subtraction between them for now, but I rewrote negative 3/4 x minus 1/5 as negative 3/4 x plus negative 1/5. And then I want to use that additive inverse. So the additive inverse of negative 3/4 x plus negative 1/5 is positive 3/4 x plus a positive 1/5. So I changed my subtraction to addition, and then I did the additive inverse of negative 3/4 x plus negative 1/5. So this is going to become negative 1/2 x plus 3/4 x once I put my like terms side by side, and then my constants are 7/10 and 1/5. When I do negative 1/2 x plus 3/4 x, that is going to get me 1/4 x. 7/10 plus 1/5 is going to get us 9/10. So our final solution here will be 1/4 x plus 9/10. Now, I know this can be a bit overwhelming. This is something we will review a little bit more tomorrow. Adding and subtracting linear expressions is something that's pretty important to be able to do. The adding part, pretty straightforward and simple, but subtracting, I realize, is probably going to take a little bit more practice. I assure you, if you follow the steps, change things in the parentheses to addition first, change that subtraction between the parentheses to addition, and then add that additive inverse. So that means making everything in that second set of parentheses its opposite. You're going to have better success or more success on these kinds of problems. I appreciate you listening, and of course we'll do some more practice moving forward as well.